Hello, today we're going to work with scientific notation with positive powers of 10. Scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to 1 and less than 10 and a power of 10. So when we are talking about very large numbers, it's a lot easier if we write them in scientific notation. It creates less number of zeros that we're working with. So here we have the weights of various sea creatures are shown in the table, and we're going to write the weight of the blue whale in scientific notation. So here we have the sea creatures that they compared are blue whale, gray whale, and whale shark. The weight in pounds is 250,000, 68,000, and 41,200. We are working with the blue whale, so we're going to work with this one right here. So we see that a blue whale weighs 250,000 pounds, and we want to write it in scientific notation. And it says that it's a number greater than or equal to 1 and less than 10. So that means that we can use any number between 1 and 9, and then a power of 10. So times 10 to whatever power we need it to be. Okay? So when I'm looking at 250,000, the decimal starts here. And we're going to move that decimal left as many places as we need to until we get to this any number between and equal to 1 and 9. And I happen to know that 2 is greater than 1, but less than 9. And so that decimal is actually going to move there. So it's going to be 2.5. And then we're going to multiply it by the power of 10. So we moved it 1, 2, 3, 4, 5 times. So it's going to be to the 5th power. Okay? We're going to go ahead and move on. It says the decimal place moves 4 places to the left on this one. So that means that's your exponent. So the number of movements is your exponent. Example 1, the distance from Earth to the Sun is about 93 million miles. Write this distance in scientific notation. So what I like to do is I like to write the number. And then I know that the decimal point is here. I know it needs to land here. So I need to know how many times it moves. So we're going to move it 1, 2, 3, 4, 5, 6, 7 times. So then it's going to be 9.3 times 10 to the 7th power. This math talk has a good question we're going to work with. Is 12 times 10 to the 7th power written in scientific notation? So does this fit the rules? Is this number between 1 and 9? No, it's greater than 9, isn't it? So that means that no, it is not written in scientific notation because 12 is greater than 9. If we were to write it in scientific notation, we would have to move that decimal between what two numbers? Between the 1 and the 2. Okay? So we're going to write each of these numbers in scientific notation. For number 3, 6,400, where would the decimal go? Between the 6 and the 4. So we would have 6.4. And the decimal would move from behind 1, 2, 3 places. So times 10 to the 3rd power. On number 4, we have 570 billion. And we need to put it in scientific notation. Where would the decimal go? If you said between the 5 and the 7, you were correct. So 5.7 times 10 to what power? 3, 6, 9, 10, 11. 11 exponent. Number 5, the light year distance that light year travels in a year is equivalent to 9,461,000,000,000 kilometers. Write the distance in scientific notation. Where would the decimal go? Between the 9 and the 4 is correct. So we would have 9.461 times 10 to the 3, 6, 9, 12. Sometimes we're writing them in standard form. And in cases like this, is we're taking it from scientific notation and we're putting it back into a standard number. When we're doing that, we take and we write our number without the decimal point. Okay? Because this time the decimal needs to move to the right because we're undoing it now. And we're going to the right 6 places because my exponent was 6. So we're going to go 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So that means that our answer is 3,500,000. So let's try this. We have 7 and 34 thousandths, and we want to or times 10 to the 9th power, and we want to put it in standard form. So this decimal is going to move how many places? 9 places. So we have 7, 0, 3, 4. Write down the number without the decimal, and then count the movements. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Then go back and put in your commas. And so we get 7,034,000,000,000, or sorry, 7,034,134,000,000. Oh, I can't say that today. Then we have this one. We have 2 and 36 hundredths times 10 to the 5th power. Go ahead and write it in standard form. Your answer should have been 236,000. Got rid of the decimal, wrote down the numbers, moved the decimal 5 places. 1, 2, 3, 4, 5. Number 10, the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6th grams. Write this mass in standard notation. 5 times 10 to the 6th power is 5 million butterflies. If you have any questions, make sure you talk to your teacher.